So carbon capture, we split into two separate buckets. The first is point source carbon capture. So where carbon is emitted into the atmosphere from industrial processes or other areas such as power generation, steel, cement manufacture, fertilizers, or even hydrogen production. And you capture the carbon dioxide at the point of emission and prevent it reaching the atmosphere. So the second is direct carbon capture or direct air carbon capture. That's taking the existing atmosphere and processing it to remove carbon dioxide from the atmosphere. So that will go in, remove CO2 as pure carbon dioxide, and then put fresher air back into the atmosphere at lower carbon concentrations. Both of these are going to be required if we're going to reach a 1.5 degree pathway. Point source carbon capture will prevent us putting additional CO2 into the atmosphere, which is obviously very important. But the current concentration is far too high, so we have to be removing it from the atmosphere in addition to preventing our existing emissions. So the benefits of carbon capture within the frame of the Sustainable Development Goals really fit with driving on that 1.5 degree pathway, because you're preventing emissions into the atmosphere and also decreasing the carbon dioxide concentration within the atmosphere with direct air capture. The interesting part about carbon capture when we talk about it in the frame of the energy transition then broadens that scope within those goals, because it really essentially is a transition technology. What it does is not prolong the life of hydrocarbon industries through decarbonising those and essentially prolonging the use of fossil fuels, but it gives other parts of the industry and other parts of the energy transition the chance to plant their seeds and grow and reach scale. So something like renewables, we can't change our grids over to fully renewable power overnight. That requires time and requires base load switchovers and storage and hydrogen to grow. Carbon capture gives those industries time. And while not impacting, I guess, our ability to run the world the way we know it with any significant detriment. Beyond that, I mean, there's some industries that are just very hard to abate. They don't have good electrification options through renewables. They don't have other options. So areas like cement is a prime example where carbon capture will be a long-running piece of technology, because not only does it emit a huge amount of CO2, there's going to be a huge infrastructure requirement and investment which will require additional cement. But cement can also be used to store CO2. So it makes a nice piece of circular economy that will drive a lot of the Sustainable Development Goals and where we want to be in the future. So with any new technology, there are always associated risks. Carbon capture is by no means exempt from that. It is an established technology. It has been around for a long time, just not at the scale. One of the issues that we're seeing within carbon capture is the scale at which it needs to be deployed. That we almost cannot move fast enough to reach the number of facilities we require globally. So there's a very strong technology risk around building and scaling the technology and getting it deployed. Beyond that, there's a level of public perception around carbon capture that it's almost like greenwashing, which it's doing the opposite of. It's genuinely taking CO2 out of the atmosphere or preventing it reaching the atmosphere. So they were the only two major risks that we currently see. Beyond capture, there's an additional part to the value chain, which is where you get into the utilization and storage. There is a public perception risk around storage, because carbon would then have to be stored, which is traditionally done in either a depleted oil reservoir or in a saline aquifer. There's continued public perception around potential seismic activity, other areas around containment in those reservoirs as over a longer duration of time. These risks are not terribly well founded. There are examples in Norway, such as the Sleipner field, which have been storing carbon dioxide for over 20 years with no leakage. So there are risks, but they're mostly perception risks as opposed to strong technological risks. So carbon capture is very heavily reliant on government regulation. So they're pushing for private companies to essentially establish carbon capture and deploy it on their operating facilities. However, there's not a great business model for it currently because you can't sell the carbon dioxide. So governments are pushing regulatory models and tax frameworks. So for instance, in the US, you have 45Q and the LCFS in California as well, which are tax regimes which help companies justify the business case around deploying carbon capture by giving tax credits in accordance with every ton of carbon captured. Within the UK and the EU, we established an emissions trading scheme, which puts a price on carbon, which again generates a business model, because everything you don't emit, you don't have to pay that trading scheme essential tax on as well. So when we talk about carbon capture, we normally talk about hard to abate sectors, some of the largest emitting sectors in the world, like cement, concrete, steel, power generation. So it's a very important technology, but it's something that's very intangible and something we don't often understand or can't relate to. There are companies, though, that are trying to bring that scale down and make it into something that we can sort of, as individuals, perceive as something very real and tangible. One of those companies is putting a small carbon capture device on the back end of your boiler. So the gas that you burn to heat your water up for your shower in the morning then gets turned into a powder, which is then converted into a soap. Another company is using a direct air capture technology to take the CO2 out of the atmosphere, but then they're turning it into consumer goods like sunglasses, replacing plastics in the overall value chain there, reducing carbon 2 times. So what we're seeing is like these smaller companies coming up with some really creative uses for carbon dioxide in ways that we wouldn't have otherwise thought of previously. And those companies are just starting to crop up all over the place. It's a very exciting time for carbon markets and turning carbon into usable products.